All right, so we're going to talk about piecewise functions here. And the top part here is basically the explanation, and then everything else is going to be examples. So if you remember when we talked about absolute value, if I take the absolute value of -4, for example, if I take the absolute value of -4, what does that become, Eli? 4 becomes +4. If I take the absolute value of 7, what does that become, Ryan? Just stays 7. So when I'm taking, if I could write this here. So if I've got -4 becomes 4, absolute value of +4 is also 4. So within that absolute value, my x could be positive or negative. And if we graph an absolute value function, it looks like this. Now it looks like one continuous graph, and in lots of ways it is, but it's actually called a piecewise function. And that means that the graph is broken into separate pieces. We can get some really cool piecewise functions. In fact, you guys saw them back in grade 10. If you had me for domain and range, I might have given you a graph that looked like this, and then went down like this, and then went across like this. That's a piecewise function. It actually has a different equation for each segment or each section. And we get into that in calculus. It's actually really cool because you can graph them on your calculator. It's a lot of work, but it's pretty cool. But what's important with absolute value for you to know is that we have to deal with two cases. And when we get into solving absolute value equations, you're also going to be dealing with two cases. So we deal with the positive side and the negative side. So when we have absolute value of x, we can have a positive x within those absolute values, or we can have a negative x. And so we're just looking at how that graph is behaving. And so something I've got extra to write here is that each absolute value can be written in pieces with the domain. So anytime we have absolute value, so each absolute value can be written in pieces with the domain. And that's because they're behaving differently depending on whether x is positive or negative. And so if we're looking at this original function, okay, if I were to look at the original function here, the original function could have, you remember when we did that question where we were drawing what it could look like? It could go down like this, okay, meaning this is my original f of x, or it could have gone down like this. So we don't know exactly what the original looks like, okay, but we can look at how the graph is behaving. So if we are looking at this section of the graph here, I'm going to look at the blue graph. If I'm looking at this function here, the original function would have been the blue graph, okay? And then when we flip it up, it's going to do this. Well, on the original function, this part of the graph is positive. And on the original function, this part is negative. So now when we take the absolute value, this part flips up. This is what we would call the positive part of the graph, and this would be the negative part of the graph. So what we can say is when x is positive, all of my x values are, this is written for the other one. So if I want to write it using the blue one, I would say that when all of my x's are positive, then when all of my x's are positive, then all of my x values are greater than or equal to 0. And when all of my x values are negative, then all of my x values are less than 0. So what that means is that if x is positive, that means 1, 2, 3, 4, 5, 6, x is greater than or equal to 0. That means all of my x values are bigger than 0. We're just dealing with absolute value x. I'm going to explain it better with an example here. Yeah.
Why would it not be like x is lesser than or equal to 0?
That's what I'm just, give me 1 second. We're getting there. Okay. So if I put these values in here, whatever values if I put x values in here that are positive, then that means all my x values are greater than or equal to 0. If I put in values that are negative, that means they're smaller than 0. Now the question comes up, well, why don't they both have greater than or equal to? Because the graph can't be positive and negative at 0. 0 can't be both positive and negative at the same point. So we have to put the equal to sign either with the first one or the second one. You can actually write it as x is greater than 0 and x is less than or equal to 0. That is still a correct answer. But the convention is to put the equal to sign with the positive. Okay, so you in a textbook, you will see it with the positive. If you put it with the negative, as long as you don't put an equal to sign with both, you're still fine. Yes.
So 0 can be positive or negative, but it can't be both.
Right. When we're dealing with the graph, because at that particular point, either the graph is positive or it's negative. It's not. It can't be both. All right, now I don't know that I've explained it clearly enough yet. So let's take a look at an example, because when we're dealing with absolute value of x, well, it's pretty easy to see that x is positive or x is negative. As soon as we add in other expressions, it gets a little harder to determine what's happening. Now, some of you, if you're familiar with transformations, might already know what's happening to this graph. If I take the absolute value of x minus 3, which way did the graph shift?
Right.
Went to the right 3. Okay, so if I want to do a quick sketch of this graph, 1, 2, 3. We talked a little bit about that yesterday. There's my absolute value. Now, if we think about what x minus 3 actually looks like in the beginning, x minus 3 looks like that. It's terrible drawing, but x minus 3 would look something like that. And so the original, I find it always easy to go to the original. The original part of the graph was positive here and negative down here. So this is the positive part of the graph. This is the negative part of the graph. So when we look at our cases, we want to consider when x minus 3 is positive, and we want to consider when x minus 3 is negative. So we're going to write y equals absolute value of x minus 3. And that equals, now you're going to use this big squiggly bracket, and we're going to write the positive case and the negative case. If I was getting into a bigger piecewise function, like let's say, for example, I had that one I drew before, well, then I would actually have to consider 3 separate pieces for my domain. But we're not going to be doing, well, and there will be 3 pieces when we get into the quadratic. Okay. So here we have the positive case. So we're going to consider the positive case when x minus 3 is positive. Okay. When x minus 3 is positive, remember right here at 3. Yeah, right there. So when we're looking at x absolute, or when we're looking at when x minus 3 is positive, that's happening when all of my x values are getting bigger or smaller than 3. This part of the graph is positive, and as this goes up and 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 up, this is going over this way. So are my x values getting bigger or smaller? Bigger. So we write comma. So this is the positive case of x minus 3 such that x is greater than or equal to 3. Now the negative case of x minus 3. Now notice I've kept the x minus 3 in brackets. I can absolutely write that. I could change that and write negative x plus 3. And sometimes you will see it written that way. So you can carry the negative through if you want to. I tend to just keep it in brackets. Okay, but you could see it written with it carried through. And so we have absolute value negative, or so we've got the negative case, negative x minus 3. When is that graph negative? It's negative here, 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 here. When x is less than 3. And notice we're going to keep the equal to sign with the 3. Remember the first time I started teaching this, and I'm like, why is there an equal to sign there and not there? And yet it really just comes down to conventions. Okay. Yeah, oh, for sure. Any questions? All right, do you guys want to try writing one on your own? Okay, so let's maybe skip. This next one is the same type of question, so let's skip that one and let's go right to, yours is different.
We just have 2x minus 4.
All right, let's go to the 2x minus 4. I want you guys to try writing the 2x minus 4. Yeah.
So when you write in the x minus 3, you use regular brackets and not the...
Okay, yeah, good question. So you're asking about why I'm not using absolutes here. So what we're talking about, because basically we're breaking these down into the 2 cases within here. So when we take the absolute value, it's going to be positive no matter what. but we don't know inside that absolute value, was the x minus 3 a positive value or was the x minus 3 a negative value? So that's where we're considering these two scenarios here. So these are just scenarios within that absolute value. So that's why these are just brackets and not absolutes, because we're just dealing with the part inside the absolute.
And you don't close the squiggly bracket?
We're not closing it because it's just, yeah, it's not like we're doing a set, because if we close it, then we're talking about a set. This is just the domain. So yeah, so we don't have to close the squiggly. It's just again a convention. Does that help or no? Yeah. So again, when you're drawing these, think what the original is. Okay, think what the original is and then go from there. Now, yeah, I realized my notes look different. I changed them at the end of last year, and then I just haven't updated my notebook file there. Okay, so I'll freeze the screen while you guys are writing that up, and then we'll go over it. Mm-hmm.
I could say like not say greater than or equal to on my positive side, and then have my less than side equal to.
Yes.
So it depends on which
Yep.
one.
Yep. So like I said, the convention will usually be to put it with the positive,
Yeah.
but as long as it's with one of them.
So we lose half a mark if we did for both of them, or?
Yes. All right, so let's take a look at what you guys got. So here we have, we've got our two cases. Now notice that both of yours, and on your sheets, I have it labeled as positive slope and negative slope. The notes that I will post online, I haven't posted the filled in ones yet, will have more examples, okay, just because I didn't rewrite my notes. But here we should have the positive. So the original function, this part was positive, this part was negative. Some of you might also think about it as the positive slope. If this is a positive slope, then this part of the function is the positive. If it's a negative slope, then it's going to be reversed. Okay. So let's take a look at an example of a negative one. So I think in your guys' notes, you've got negative 2x plus 4. So that's over here. Okay, so negative 2x plus 4. So if I sketch the original function, it's going to come down like this. So now this part is the positive part of the graph. And when it flips up, this part is the negative piece. Yeah. Let's see, negative 2x plus 4 equals 0. Negative 2x equals negative 4. X equals 2. Nope. But no, that's a good question to have, though, because absolutely you're going to have to figure out, and I didn't go over that in the last piece here. You're definitely going to have to figure out what your x-intercept is. So that's where I set my y equal to 0 and solve for x. So for this one here, I can set negative 2x plus 4 equal to 0, rearrange, so I know that I'm going to have an x-intercept at 2, because that's critical to when I set up my domain. Now for setting up my domain, so setting this up, I'm going to have y equals absolute value negative 2x plus 4, and that's going to happen. So either this is going to be positive or this is going to be negative. So now we have to consider again the positive and negative parts of my graph. Well, the negative part of my graph is happening here, and the positive part of my graph is happening on the left, and the negative part is happening on the right. I still have my two cases. We always list the positive one first. So the positive of negative 2x plus 4. So the function is positive when x is less than or equal to 2. Notice it seems like it's reversed, but we're talking about when this part of the function is positive. So this part of the function is positive. It's getting bigger and bigger and bigger and bigger as my x values are getting smaller and smaller and smaller. But I'm still dealing with the positive case, so I've written less than or equal to 2. Now for the negative case, the negative of negative 2x plus 4 happens when my values are getting bigger. So x is greater than 2. So I don't want you guys to mix up that the equal to sign just goes with whichever one is greater. It's the equal to sign that's going with the positive case. So negative 2x plus 4 if, now I wrote a comma. You will see some people that actually write it this way. They'll say negative 2x plus 4 if x is less than or equal to 2. Negative 2x plus 4 if x is greater than 2. Okay. Now, again, you will see people that will rewrite this. So I'll write it really quickly here. You'll see people who just write this, negative 2x plus 4 if x is less than or equal to 2, and then 2x minus 4 if x is greater than 2. What did I change?
You didn't put positive order.
Right, I didn't put positive, negative case. I just multiplied the negative through. Okay, but I find this one a lot clearer when I'm looking at what I did. Whereas this one, it's harder to figure out where those numbers came from. Yes, sir.
What would happen, maybe I'm ahead of myself, but if we had a piecewise function, like you said, that had like different pieces that were completely different, like some were curved lines, some were straight lines, what would this look like?
Then we would be looking at specific. So it wouldn't be absolute value in that case. We would just be doing the domain. So if I had a graph, so we wouldn't have to worry about cases. So you won't see anything like that in 20-1. Then I would be saying the domain of this from here to here, the function is, well, okay, let me see. Let's say I did x squared. So x squared looks like this. And then I go down here at negative x. And then here, I don't know, it's like x plus 4. So this part here, or sorry, let me do that again. So, and again, you won't see one of these in 20-1. So let's say from here to here, let's say this is negative 4. So from negative 4, so it's going to be y equals x squared from negative 4 to 0. And let's say that that's a closed dot. And then it would be y equals negative x from 0 to, I don't know, 2. And then y equals, I don't know, negative 3 from negative when x is greater than or equal to 2. So I would write them 3 separate. It's written very much the same as we do here, but we're not having to worry about a positive and a negative case because it's not an absolute value. Does that make sense?
Yeah, you just break it down.
We just break it. Yeah, we go segment by segment. But again, you won't see, that's something we actually get into in calculus, but we don't do anything with it. I don't even think you do it with 30-1. All right, any questions about that one? Yes, sir.
Is there a reason that you always keep your x's on the left side? Or is that just...
When we're writing as a convention, so if I'm writing, you didn't have, did you have me for, yeah, you had me for 10C. Remember we talk about the start, there was like the start and stop functions and sandwich functions and whatever. Those are just made up names, by the way. They're not math terms. If I'm sandwiching my x between 2 points, I will put x in the middle. But the convention is we always read from left to right. So if it's just x and the number, then I will always put the x on the left. Yeah, so that's just, again, a convention. All right, do you guys want to try one on your own? Okay, so I'll give you a minute to do that. Yeah. Yeah. If we take longer to go through this today, guys, and I have to give you time to, and then tomorrow I have planned as an extra day for this, I think piecewise functions is usually quite confusing. Even if we only make it through the notes today and you can do a couple practice questions, you will still have time tomorrow after your quiz to work on the assignment piece. So don't stress about it if you're not getting it right away. I'm trying to break it down as much as I can. So again, I'll freeze the screen and write it up while you guys are trying it.
Sorry, which question?
So for you guys on yours, it is, yeah, it's 6 minus 2x. So you do that. I always find it's helpful to go to the original function. So this is negative 2x plus 4. So originally my function went down like this. So this part stayed positive. So that's the positive side. This is the part that flipped up. So the original equation was in the negatives.
Oh, I see.
Yeah. So again, you guys are doing the one on your sheet. So the absolute value of 6 minus 2x, you can rewrite that if that's easier. All right, so take a look at that. So we've got, I've just rewritten it where I pulled the negative through. So if we graph the original function, we've got negative 2x plus 6. So off to the side, I figured out what my x-intercept is. So I'm going to have 0 equals negative 2x plus 6. So I got negative 6 equals negative 2x, x equals 3. And so my graph is positive when x is less than or equal to 3, and it's negative when x is greater than 3. Does it help to start by graphing your original function? Picture your original to the positive. So when I first started teaching piecewise functions, it had been a lot of years since I'd done that. That was the part that threw me off. And as soon as I went to the original function first, then it wasn't hard to figure out which is positive and negative. So positive means it's above the x-axis, and negative would be below. Eli.
Is it like I don't graph them at all?
That's okay because you can visualize it, right? And that's okay. But for the notes, I'll still graph it because some people need to see that visual.
But you don't need to graph.
No, you don't need to graph it. No. If you were doing it on written response on a test, I'd probably show the graph so that at least I can see your process. But
Or couldn't I also solve for my
yeah, I mean, a lot of times you are relying on what you already know. All right, so let's take a look at how this works for quadratics. So quadratics are the exact same type of thing. We've already got our zeros here. So my original function, I've got x plus 1 times x minus 3. So I'm going to have a 0 at positive 3. And I'm going to have a 0 at negative 1. See why that quadratics unit is so important because it ties in with everything we do. Where's my y-intercept going to be? Negative 3. So we don't have to multiply that all out. We know it's going to look something like this. Okay, so that's the initial part. Now, we know that when we flip that up, my y-intercept is going to be at positive 3. And so my function is going to look something like this. Now, how many sections to the graph do I have? Originally, I had 2 sections. How many do I have now? There's this section here. I have 3 sections. So thinking about my original, this part here, so from -1 going down, is that a positive section or a negative section? Think about the original. The original is in blue. So this section right here is positive because it was above the x-axis. This part here was originally below the x-axis, so that's a negative section. And this section was originally above. They should match, but this will be a positive section. So we set up our function here. Try to mirror your function notation. So if this says f of x, write f of x. So f of x equals absolute value of x plus 1. I know it seems very tedious to write out all of that, but it's just getting that practice of writing at the proper notation. Equals, now this is where we set up our cases. So there's still the positive case. Okay, now some people will multiply this out. So the positive case of this, if I multiply this out, it's going to be x squared minus 3x plus 1x minus 3. So that's x squared minus 2x minus 3. So I could just write x squared minus 2x minus 3. Now, my function is positive when x is less than or equal to -1. And when x is greater than or equal to 3. So it's positive in both of those points. Now you will see, and I don't do a lot with it, we don't do anything with it in 20-1. This can be written in what's called interval notation. So it's positive from -infinity to -1. It includes the -1. It does not include. So do not, this red part you do not have to write. This is a calculus thing. And you'll see it in 30-1. So from -infinity to -1, square bracket means it's included, round bracket means it's not. Union 3 to infinity. Infinity is never included. So that would be how I would write that exact same piece of information in calculus. Okay, interval notation is actually easier to work with, I find, but we don't do anything with it in 20-1. All right, then the negative case of that, so the negative of x squared minus 2x minus 3, well, the negative case happens when we're going from -1 to +3, so in between those 2 points. So going back to grade 10, we're going to sandwich between those 2 points. So if you had me last year, you've heard me explain this before. If you did not, hopefully this will help clarify things. This is the one I used to struggle with. So write your low bound, which is -1. Write your high bound, which is 3. Sandwich the x in between them. You guys remember the last part? If you had me, you've heard me say this before. Low bound, high bound, sandwich in between, and then the alligator eats the bigger number. Okay? So whenever you're sandwiching between 2 points, put your low bound and your high bound, put your variable in between, and then your signs will all open to the right. So you'll always have the alligator eating the bigger number. Okay? Questions? Now you will see some people who will carry this through, and if you're looking at an answer key, it might say -x squared plus 2x plus 3. That is exactly the same thing. Okay, I do not expect you guys to have to carry it through the brackets, but you need to know how to recognize it if someone did. All right, do you guys want to try the last one on your own? Okay, so I'll give you a chance to try that one there, and I'll freeze my screen again and put them up. So it will help to start by factoring. You could just put a comma as well. Yeah. All right, so let's take a look at this one. So this one here, I did not graph my original. Instead, kind of piggybacking off of what Eli was talking about there. So I just sketched my original. I know that everything's going to be above that x-axis. Okay, it probably is helpful to at least do a sketch and show what your positives and negatives are. For me, when I'm marking your assignments, that tells me whether you're misunderstanding the positive and negative, or are you misunderstanding the piecewise part. Because if you get this wrong, but then you do this right based on this, well, then I know my conversation with you has to be about your positives and negatives. If you're doing this right and then making mistakes here, well, then that's a different conversation. So that's why it's important for you to show your work so I can see what your process is. And so here I know that this graph is opening down. So that means I know that those bottom tails would have originally gone down here and down here. So that would have been my negatives. So the positive is happening between -6 and 6. So I put my low bound, my high bound, x in between. Alligator eats the bigger number because it's the positive case. I've put my equal to signs. For the negative case, x is negative when x, or this function is negative when x is less than -6, or and when it's greater than 6. Okay, I'm not going to get into the ors and ands too much now. That's more for set notation or set theory. Now, again, you could see this written two different ways. I could bring in that negative and have -36 plus x squared, or I could have rewrite that as x squared minus 36. Those all three mean the same thing. Yes, sir.
Start by factoring, but what if we didn't factor and just put that in our calculator and got our -6 and +6 from that?
You can, but what if they weren't nice numbers, right? Like sometimes you're going to get decimal answers and your calculator might not, you might not know what that decimal is without having factored it. So yeah, I get where you're going with that, and you're still going to have the right answer for sure. The most important part is that you can do this piece here. But if I'm doing it completely algebraically without using my calculator, then I would have to factor. Yeah, or not even that. I could also say 0 equals 36 minus x squared. Sorry, I'm writing too fast. Yeah, exactly. I know it's positive or negative, and when I square root, it's plus minus. Yeah. All right, so I'm just going to stop the recording here.